Welcome to Module 3 of the Grade 7 Math curriculum. And this presentation is going to be a short one, but a very important one, and one that I'm hoping everyone is doing prior to beginning with the lessons. Okay, and this is going to deal with relevant vocabulary. Okay, relevant vocabulary. Things that we need to know before we begin, so we're not tripping over this vocabulary. Okay, so here it is. This is actually this page of relevant vocabulary actually exists in your binder in lesson 1, at the end of lesson 1, and it's right there, right before the problem set, and it is called relevant vocabulary. You're going to see it looks just like this. Okay, it's at the bottom, and I'd like to go over these terms before we begin, so as to hopefully make this module, which is challenging, a little less so for all of you. Okay, so yeah, the first bit of relevant vocabulary here is variable. Okay, we've been talking about that. And if we look at our description here, a variable is a symbol, such as a letter, that represents a number, i.e., for example, it is a placeholder for a number. Okay, and that's it. If we could just think of a variable as a placeholder, and it's very often a letter, okay, and we've seen letters such as X used, and N, etc. It can be anything. Anything that makes it easier. What you will see X, you'll see Y very often. Okay, what it does, it's where a number can be inserted. Okay, a variable, it holds the place for a single number throughout all your calculations done with the variable, and it does not vary. Okay, it is the user of the variable who has the ultimate power to change or vary what number is inserted as he or she, that's you or me, desires. Okay, the power to vary rests with us. Okay, with us, you, the student, me, the teacher, and not with the variable itself, because that X is always going to stay X. Okay, so for example, if we say X minus 350 equals, actually let's redo this here. Let's just create an expression, and I want to create a profit expression. Okay, so if we're going to say our profit is equal to, and we did this actually in I think the end of the module assessment last time. So if we say that we sell, remember we were talking about selling Christmas ornaments. So if we had 5x, and this x, this variable here, stood for the number of ornaments sold. Okay, a number of ornaments sold, and then minus 3.5x, and remember this x is still the number of ornaments sold. Okay, and this was our profit. Okay, so this was our profit. This is our profit expression. We know how much money we make on each one of these ornaments based on this expression. Okay, now with the 5, what this 5 is, this is how much money we actually we get for each ornament. The 350 is how much we pay for each ornament, our expense. Okay, so it's very expensive, let's say in this case, to make these ornaments. All right, so by plugging in a number, and again this is for us to do and us to decide, because we know we want to project how much money we might make on the selling of these ornaments. So this X, let's say we want to know, okay, how much money are we going to make if we sell 10 ornaments? What we do then is we plug in 5 times 10. Okay, here's our X now is 10 minus 3.5 times 10. And again, here's our x, and these are the same, okay? See, so x here and x here both equal 10 down here and 10 over here, okay? They don't change, okay? They don't change here. The two x's are always going to stay the same, all right? We can change what x equals, okay, because we are plugging this in. So if we just continue this, we know 5 times 10 is 50, minus 3.5 times 10 is 35. And now we can complete this, and that equals 15. So this is $15 here is our profit on selling 10 ornaments, okay? If we sell 10 ornaments, we make $15, okay? And yeah, so that's basically what a variable is, the variable in this case being the x. Okay, we change it as we are either assigned to change it by the problem we're given, or by what occurs in our lives, for example. Okay, so the next relevant vocabulary here is numerical expression. Numerical expression, description. So a numerical expression is a number or any combination of sums, differences, products, or divisions of numbers that evaluates to a number. Okay, the difference here, and one thing we could say is there, without an equal sign. Okay, so we don't have an equal sign when we're writing an expression. Okay, so right here, when we wrote this here, this is our profit expression. Okay, there is no equal sign, all right, because we don't know what anything equals here, okay, because we're going to get that when we plug in our number, such as the 10, for our variable, which was the x, okay? So this right here is an expression. It is not an equation because there is no equal sign, and that's what differentiates an expression from an equation, okay? So the next thing here is the value of a numerical expression, and the value of a numerical expression is the number found by evaluating the expression, okay? And evaluating is just, figuring out or plugging in numbers. So for example, if we use our example here, the value of our numerical expression in this case right here was the $15 after we plugged in our 10 for x, okay? So that is the value of our numerical expression, right? After we plug in for our variable, all right? And yeah, okie doke. Okay, and expression, this case here, expression as a description. An expression, we say, is a numerical expression, okay, or is a result of replacing some or all of the numbers in the numerical expression with variables, okay? So, because this is basically what we're going to see. We're going to see we're going to see an expression like this, okay? Now, I guess the way they are differentiating those is right here. This would be more or less a numerical expression here because we have all numbers plugged in. Okay, 5 times 10 minus 3.5 times 10. Okay, numerical expression has the numbers plugged in. The expression is this one here, where we have our variables included. Okay. Now, equivalent expressions, we talked about this before. Equivalent expressions are equivalent if both expressions evaluate to the same number for every substitution of numbers into all the letters in both expressions. So, for example, let me just go beyond this. So, we had this one, 5x minus 3.5x. Now that expression would be the same as 1.5x, okay? Because for any for any value for x for the variable, these are going to come out the same. Okay, so let's say we plugged in 10. Again, these are two separate expressions here. If we plugged in 10, as we did before, for the variable x, okay, so then we'll just redo this. We did this already, but it's worth redoing. Okay, so what we're doing here is we're taking that first expression right here, this one, and we are plugging in 10 for x. Okay, and we remember where that equaled 15. Okay, and again, this was $15. All right, because this was 50 minus 35. Okay. Now, if we went ahead and used this expression, 1.5 times 10, which is what this is saying, I'm plugging in 10 for the x, that also equals $15. Okay. So these two here are what we consider equivalent expressions. Okay. These are equivalent expressions right here. This one and this one. Because they are going, for any number that I substitute in for the variable, it's going to be the same. So we saw that 10 worked. Okay, we can just prove this by let's use another number. How about we say 20? Okay, let's substitute 20 in for x. So that would be 5 times 20 minus 3.5 times 20. Okay. And so this is going to be 100, and this is going to be 75, or sorry, that's right, yeah, 75, and that equals 25, okay, all right, and then if we do 1.5 times 20, okay, looks like something has, oh, I did it wrong, I'm sorry, this is not 75, this is 70. Excuse me, sorry, it does happen. Okay, so this is 30. All right, so again, I'm plugging in 20 for my x now. And so 5 times 20 is 100. 3.5 times 20 is 70. That's 75. And so my total here is 30. And then if I went ahead and I did plug in my 20 for my x here for the second expression, and that also equals $30. Okay, so we've proven again that these are equivalent expressions. So these are equivalent examples of equivalent expressions. Okay. Now right here, this next one, it's talking about a. Okay, sorry to stop there. I was sneezed. But anyway, we were on an expression in expanded form. That's right over here. Okay. Now, I know you guys have seen these terms before. You've seen expanded form and you've seen standard form. Okay. They're going to use this quite a bit in this curriculum, so we do need to understand it. Okay. So an expression that is written as sums and/or differences of products whose factors are numbers, could be variables, or variables raised to whole number powers, as in, whatever, x squared, for example, is said to be in expanded form. Okay, expanded form. Okay, a single number, variable, or a single product of numbers and/or variables is also considered to be in standard form. Okay, so the thing is, expanded form is very expansive in its definition. So pretty much anything or everything could be considered expanded form, okay? But it will change, only certain expressions can be called standard form, okay? So let's just look at here. So expanded form, examples of expanded form could just be the number 324, okay? 3x, okay, very simply, just 3x itself. 5x plus 3 minus 40. Okay, it's also considered expanded form. And then x plus 2x plus 3x is also considered expanded form. These are all considered expanded form. Okay. But now, if we look at, I'm going to go down to standard form now, just so we can make that comparison. Okay. An expression in standard form down here. Okay. Is defined as such: an expression in expanded form with all its terms collected is said to be in standard form. Okay, this idea of terms right here, we could just go back to this definition up here, term, and term is right over here. This idea of terms is each summoned of an expression in expanded form is called a term. Okay, for example, the expression 2x plus 3x plus 5 right here consists of 3 terms. Okay, 3 terms, which are this one, and this one. Okay, so those are terms. All right, if you look over here, we have 3 terms for this one as well. Okay, for this expression, 5x, and then 3, positive 3, and negative 40. Here's another one. There's an x, 2x, 3x. Okay, those are 3 terms. It's a 3-term expression as well. Okay, so that's what these terms are. They're meant by terms right here. Okay, so an expression is an expanded form with all its terms collected is said to be in standard form. Okay, so for example, this one right here, this expression 2x plus 3x plus 5 is written in expanded form. Okay, as pretty much everything is. However, to be written in standard form, the terms 2x plus 3x must be combined. Okay, so the equivalent expression is 5x plus 5, and that is standard form because each term is unique in the sense that there's only one x term, and there's only one 5, and we're going to give that a number too, give that a name as well. Okay, so for example, if we go back to, let's see where we had this here. Okay, actually, but this one. Okay, so if we look at these expressions, you'll notice that this one here is expanded form. Okay, and this is also expanded form, okay, because that definition is very expansive. All right, but you'll notice here we cannot call this one standard. Okay, this is not standard. We'll have to put a little standard form. We can't call this one standard form because there are 2 x variables in it. Okay, 2 x variables. But this, yes, is standard, okay, in standard form because it has only the 1 x variable. Okay, these two here have been combined to get that. Okay, to get that. So this is standard form. Yes, indeed. This over here is not. All right. So again, we'll make this clearer and clearer as we go on, but something that's good to know. Okay, so here we are back at our relevant vocabulary. Yes, the last thing we had here we talked about was an expression in standard form down here. Okay, the last definition they have here is actually a term I've been using, and hopefully not confusing you, but the term is coefficient of the term. This idea, this word here, coefficient. Okay, now the number, a coefficient is defined here as the number found by multiplying just the numbers in a term together. So for example, if you're given the product 2 times x times 4, its equivalent term is 8x. So that number 8 right here, the number 8, is called the coefficient. Okay, it's the coefficient of the term 8x. So if we go back and look here, okay, keep going the wrong way. Okay, so if we look here at this right here, 5x, this is like a 5x for example, this 5 is the coefficient. Okay, that's called the coefficient, all right, of the variable. And a coefficient exists before a variable. Okay, that's the only time you're going to have a coefficient is because what it's saying, hey, we need 5 of these variables, okay, 5 of these. The coefficient determines how many of these x's we need, okay, and in this case here, this 3.5 as well is a coefficient, okay, a coefficient of this variable, all right. Now if we were to combine these, Actually, it's actually not 3.5, it's actually negative 3.5. Always got to pay attention to that. Okay, when we combined those, remember we ended up with this, and we had it in standard form. So here we go, we have a standard form, and then the coefficient here is 1.5, okay, because it tells you how many of those variables we want. Okay, so that's what that coefficient does. It determines how many we need. That is the coefficient there, okay? Again, some new vocabulary for you, maybe new, some of it not new. Please study this, go back to it. Again, it exists there in your lesson 1, at the end of lesson 1. Refer to it whenever you need to, okay? All right, so now you're ready for lesson 1 of module 3, topic A. So go and get it.